Lessons 8, 9, and 8 are on optimization problems, and I've broken this unit in the textbook into three little pieces, and we're going to build up to the big ta-da, doing everything from scratch. So I'd like you to just pause the video for a sec and read through the vocabulary and the steps to creating a model and familiarize yourself with the wording. Okay, so we're going to come back to all those things as we work through the next three little videos. But for right now, I want to remind you of some number systems that we work in. So we're going to need to worry in the real world really with three kinds of numbers. Natural numbers. Natural numbers are the first numbers we learn, and they're like this: 1, 2, 3, 4, and they go up. And what we're going to have in our system is we're going to have two things that are happening, and we're going to be really simple with what we call them. We're going to call them x and y, so we can graph. Now, x and y might represent some real values, some real categories, but we're going to treat them as x and y. And what these two little statements say is x is a natural number and y is a natural number. So it's funny looking, looks like an e. All it means is a part of. So when you see something like x, e, n, it just means x is an element, x is a part of the natural number system. It can only be those kind of numbers. W are whole numbers, and W simply adds one number to the natural number system, and that's the number 0. 0 didn't come along for a while. And similarly, some of the problems need a 0. So you're going to see x and y are part of the whole number system. And then finally, you have the real number system. And the real number system is a capital R. And the real numbers are just all the numbers we know. So whenever you see the word real numbers, just think all the numbers you know. So you know positive numbers, you know negative numbers, you know fractions, you know decimals, things like that. So again, negative, 0, positive numbers are real numbers, decimals and fractions are real numbers, and roots, like for instance, square root, cubed root. So roots, the square root of something, the cubed root of something. These are all the real numbers that we know. And again, the easiest way to think of real numbers are the kind of numbers that you deal with every day. Okay, so, so here's what we're going to do today. We're going to start to put together how to solve a problem by taking little steps. And in this first example, Jack has to buy pop for a family movie night. They need at least 3 liters of cola. They need at least 6 liters of Dr. Pepper. Jack has enough money to buy a maximum of 12 liters total. And what we're eventually going to do is we're going to solve problems like this. But for right now, we're going to step through. So one of the first things we're going to do is we're going to define our variables. We're going to read the question, and based on what we need to find, we're going to have to define them. And again, we're always going to use x or y. It just makes it easier to draw. So in this one right here, what we're going to say is x is the number of liters of cola that Jack might buy, and y is the number of liters of Dr. Pepper. So those are the two things that can change. Now, in the story, we are given information about how much cola he can buy, right? So in the story, you're told they need at least 3 liters of cola. So this is how we write that. At least 3, meaning it can be 3, 4, 5, whatever. But remember, there's a maximum on there. So y can be greater than or equal to 3, but less than or equal to 12. And similarly with the Dr. Pepper, they need at least 6 liters of Dr. Pepper, so they can have 6, 7, 8, 9, whatever. and y has to be less than or equal to 12. Now, right now, you might look at this and go, yeah, but I know they're not, I know they can't be 12 because we need three of the other ones or six of the Dr. Pepper, but it's not a big deal. So we'll leave it like that for now. The other kind of thing is, well, what kind of numbers can it be? Well, again, they can only be whole numbers, right? You can't buy, or in fact, natural numbers because we're limited. But you can have decimals. That's the big idea. You can't buy 3.72 liters of Coke. And then finally, if we put the last thing in our inequality is, well, we do have another story, and it is Jack has enough money to buy a maximum 12 liters in total. So again, he buys some of the Coke, Cola, he buys some of the Dr. Pepper, but he can buy a maximum of 12. And again, those numbers can't be decimals. There's a whole infinite amount of numbers that add up to 12. But again, we are only interested in those whole numbers. And again, this idea of a whole number is it cannot be negative. And again, it makes no sense, right? It makes no sense buying negative cola. So again, what we're going to do eventually is we're going to put these all together. But today, we're just walking through the story, and we're going to define our variables and write the inequality, and that's it. So let's look at another example. A farmer is going to plant corn and beans, and she has enough seed to plant 4 acres of corn. She has enough seed to plant 6 acres of beans, but Buffy only has 8 acres of land. So in this story right here, she has enough seed for 10 acres, but again, she only has 8. So again, what we might decide is, well, X is the acres of corn. Now, if you did this yourself and you said X is the acres of beans, it really doesn't make a difference. As long as one of them is X and one of them is Y, and Y then would be the acres of beans. So again, what can change? When we see this, you have to read the story and you go, well, what can change? And again, most of this is logical. So how do you write this sentence mathematically? Buffy has enough seeds to plant 4 acres of corn. Well, again, really what that says is she can plant no acres, 1 acre, 2 acres, whatever. But also, again, she can actually plant she can plant 1.2 acres, 1.5 acres, 2.7 acres, etc. She has enough to plant 6 acres of beans. Again, same idea. She could actually plant, 3.5 acres. So we could have decimal. So in this one right here, Buffy has 8 acres of land to plant. So if some of that is corn and some of that is beans, then if she has 8 acres, well, we could write that. But remember, we're writing inequalities, and this is the one we really want. And the reason we want this one is this really doesn't make sense, but she doesn't have to use all her land. So that's why it's important to have that less than. Maybe she wants 1 acre not in use. And then the other thing we have to notice is there's no such thing as negative acres. So X has to be greater or equal to 0, and Y has to be greater than or equal to 0. So again, we're just reading the story today, and we're defining our variables. And again, each sentence in the story tells you something. And I'm cueing you right now, but eventually you have to put it together. So one last example. 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches, 14 athletes. Each car can take 4 members. Each minivan, 6 members. No more than 4 minivans and 12 cars are available. So the school wants to know the combination of cars and minivans that will require the minimum number of vehicles, and the maximum, right? So in this one right here, I just want to introduce one thing, and it's called the objective function. And the objective function, we're going to build on it next day, but the objective function is really the thing you want to solve, the thing that's going to give us our answer at the end. So in looking at this thing right here, really, I don't care about that there are three teams. I just care about, each team. So identify the quantities, identify like what you are changing, and this helps you define your variables. So in this thing right here, the quantity that we want to actually determine is the number of vehicles. So this is identify the quantity. I guess it should be identify the question. Identify the question you want to be answered, and it's the number of vehicles. And the vehicles can be cars and vans. And then that is the quantity we want to maximize or minimize. So identify the quantity to maximize or minimize. And you're going to see down in step 4, the objective function, this is going to be important. So the number of vehicles is equal to, well, the number of cars that we rent and the number of minivans that we rent. Okay, so again, if there's 16 people, I guess we could rent four cars, and we could rent 4 minivans, or depending on how you're thinking about this problem. Okay, so if we looked at this individually, it's a little bit different than if we looked at it as the 3 teams. But anyway, we'll work our way through. So define our variables. So again, what can change? Well, not the number of people. The number of people is right there. What can change is, well, how many cars you rent and how many vans. So I'm going to call X the number of cars. And Y then would be the number of vans. So this is what's going to change, and this is ultimately the question: how many cars, how many vans should we rent? Okay, now we're going to write those inequalities. And in our inequalities, it's in bullet number 3 that you kind of see it. Well, the number of cars has to be greater than or equal to 0. You can't have negative cars, but there's only a maximum of 12 cars. So again, X has to be less than or equal to 12. And again, in this thing right here, there's no such thing as 0.5 of a car, so these are going to have to be whole numbers. With the minivans, well, again, we have to rent at least 0, but no more than 4 are available. And again, it makes no sense to have negative cars. Okay, so there's those examples of what we've done so far. We've defined our variables, and then we've stated what can happen. And ultimately, we're going to use this information to go ahead and solve, but we're not solving yet. And we're going to come down to this right here. We're going to, again, generate the objective function. And in the front page of your notes, an objective function is, in an optimization problem, is the equation that represents the relationship between the two variables in the system of linear inequalities and the quantity to be optimized. So again, it is an equation, and it's what we want to answer. So we want to figure out how many vehicles we're going to have, and some of those vehicles are going to be cars, and some of those vehicles are going to be minivans. But again, we're renting the cars and minivans based on the amount of people that we have to transport. And each car can transport 4 people, and each minivan can transport 6 people, and depending on how many of these minivans and cars we rent, the number of people that will fit, let me call that, the number of people that will fit will change depending on the number of cars and things we're renting.